What do you think the end of our universe will look like? We know how it began. Around 13.8 billion years ago, the Big Bang occurred and our universe was born. But if there was a beginning, then how will it end? Humanity has wondered about this question for years, and several theories have been proposed. For a long time, one of the most popular ideas was the Big Crunch theory. According to this idea, the universe would continue expanding for billions of years, but eventually the expansion would slow down. At some point, expansion would stop completely, and gravity would begin pulling everything back together. The universe would slowly shrink, collapse inward, and eventually end in a gigantic cosmic collapse. The Big Crunch theory was once extremely popular, but recent scientific discoveries seem to reject it. According to newer observations, the expansion of the universe was not slowing down, it was accelerating. And not just slightly, but much faster than scientists had expected. Yes, our universe is expanding, and the rate of expansion appears to be increasing. But why? And what would this mean for the future of the cosmos? The most common explanation involves dark matter and dark energy. These mysterious components barely interact with anything we know. We cannot observe them directly. We only detect their gravitational effects. Because of this, scientists believe dark energy may be responsible for the accelerating expansion of the universe. However, today's topic is not dark matter itself. The important question is this: if the universe keeps expanding faster and faster, what will happen in the end? At this point, two major theories emerge. One is the Big Rip, and the other is the heat death of the universe. According to the Big Rip theory, the universe will continue expanding until the fabric of spacetime itself tears apart. Galaxies, stars, planets, and eventually even atoms would be ripped apart by the accelerating expansion. Another possibility is the heat death scenario. In this model, the universe expands forever until all energy becomes evenly distributed. Eventually, every star dies, black holes evaporate, and the entire cosmos reaches maximum entropy. At that point, no usable energy remains, and the universe becomes cold, dark, and lifeless forever. These theories exist because observations seem to show that the universe's expansion rate was increasing. But in recent years, some scientists have started asking an uncomfortable question. What if we made a mistake? What if the universe is not expanding as quickly as we thought? This issue is related to what scientists call the Hubble Tension. Let me briefly summarize it. In 1929, astronomer Edwin Hubble proved that the universe was expanding. He observed that the light from distant galaxies shifted toward the red end of the spectrum, a phenomenon known as redshift. This meant the galaxies were moving away from us. Hubble calculated the expansion rate of the universe and initially estimated it at around 500 kilometers per second per megaparsec. A megaparsec equals approximately 3.26 million light-years. In other words, a galaxy 3.26 million light-years away appeared to be moving away from us at 500 km/s. This was revolutionary, but later scientists realized the number itself was incorrect. For decades, astronomers tried to determine the true expansion rate of the universe. In the early 2000s, data from the Planck spacecraft and other observatories suggested the Hubble constant was actually around 67 kilometers per second per megaparsec. Scientists thought they had finally solved the problem, but then another method produced a completely different result. Researchers began using supernova explosions as cosmic measuring tools. While we cannot observe individual stars in distant galaxies very clearly, we can detect the enormous light produced by supernovae. These explosions act like cosmic candles, helping astronomers estimate distances and expansion rates. However, calculations based on supernovae produced a much larger number, approximately 74 kilometers per second per megaparsec. This contradiction became known as the Hubble Tension. Measurements based on ancient distant galaxies suggested one expansion rate, while measurements based on nearby supernovae suggested a faster one. Scientists interpreted this difference as evidence that the universe's expansion was accelerating over time. And this changed everything. If the expansion rate was increasing, then something unknown had to be driving it. Dark energy became the leading explanation, but many researchers were still uncomfortable with the inconsistency. Some scientists began proposing alternative explanations. One idea suggested that our galaxy cluster exists inside a massive cosmic void, making nearby galaxies appear to move away faster than they actually are. But recently, a new study may have uncovered the real source of the problem. A team of scientists from Seoul National University, Hunyoung Sun, Yangwoong Lee, Chul Chung, Sehun Park, and Hun Cho spent years researching the Hubble tension. Their findings were published in the Journal of the Royal Astronomical Society in early November. According to the Korean team, the error was hidden within the supernova calculations themselves. They argued that researchers had ignored a critical factor: the age of the exploding star. Not all supernovae behave identically. The chemical composition and brightness of a supernova depend heavily on the age of the star that exploded. This means different supernovae produce different amounts of light and energy. In simple terms, the Korean researchers argued that supernovae cannot be treated as perfectly consistent cosmic candles. If their calculations are correct, then measurements based on supernovae overestimated the expansion rate of the universe. Their revised mathematical model resolved many of the inconsistencies, and if they are correct, the universe is still expanding, but the expansion rate may actually be slowing down over time. If this is true, it changes everything. Instead of expanding forever toward heat death or being torn apart in a big rip, the universe may eventually slow down completely. Then gravity would begin pulling everything back together. The universe would shrink, collapse inward, compress further and further, and eventually end in a big crunch. If this model is correct, then we may finally understand the ultimate fate of the cosmos. And perhaps the collapse of our universe could even trigger another Big Bang in a new space-time cycle. Of course, this does not mean dark matter or dark energy do not exist. They almost certainly still do. But according to this new interpretation, their influence may be stable rather than endlessly increasing. To summarize, recent findings suggest the universe's expansion may not continue accelerating forever. The cosmos may not end in eternal darkness or catastrophic tearing. Instead, billions of years from now, everything may collapse back into a single point. And who knows, maybe that collapse will become the beginning of another universe.
Thanks so much for watching my video. I really appreciate you taking the time to be here. If you enjoyed it, don't forget to leave a like and consider subscribing. It really helps the channel grow and keeps me motivated to create more content like this. Also, if you want to be notified right away whenever I upload a new video, make sure to turn on the notification bell so you don't miss anything. Thanks again for your support, and I'll see you in the next video.